Pancholi, Assistant Professor in LJ Institute of Engineering and Technology in Department of Electronics and Communication. This video is about subject fiber optic communication. So friends, we are going to study about the fiber optic communication. As we have learned about the too many aspects of the fiber optic communication. So we started learning about the overview of the optical fiber communication. So in this video, we'll learn about the elements of an optical fiber transmission link with the functional description of each block. So now friends, we need to recall the few things which we studied earlier. It is about the block diagram of the communication, which consists of mainly the three parts: transmitter, receiver and the channel. Now, what is the function of the transmitter? Which will transmit the signal. What is the function of the receiver? Which will receive the particular signal. What is the function of the communication medium? Then it is transmitting the information from the one place to the another place. So friends, here we need to learn about the specific block diagram of the optical fiber. Now we know that what is the optical fiber? The optical fiber, that is the particularly the thin structure. Okay, and it is the hollow waveguide. It is the light pipe transmitting the information in form of the light. So friends, here we need to learn about the block diagram of the particular signal. Now here you can see the block diagram of the optical fiber, which consists of the transmitter, transmission channel and the receiver. So the transmitter will transmit the electrical signal which is applied to the optical transmitter. So optical transmitter, which consists of the driver circuit and light source and the fiber flywheel. Now we know that in the optical transmitter, the electrical particular signal is there. Now the optical transmitter will transmit the optical signals only. So we need to convert the electrical signal into the optical form. So the device which we need over here, it's a light source. The light source can be either the LED or the laser. So this particular light source will convert the electrical signal into the optical form. To run this light source, we need a driver circuit. So the optical transmitter, okay, you can see that the electrical input signal. Now electrical input signal, that is given to the driver circuit, and that driver circuit output, it is given to the light source. Now all our information available at the end of the light source, that is the information in form of the light. Now whenever we are transmitting this information, light information, that is via the optical fiber cable. Now whenever we need to transmit the optical signal at a large distance, sometimes it is mandatory to join the two fiber. How can we join? We can join the two fiber via using the optical splice. So splicing technique can be used for combining or joining the two fibers. So here we have the optical splice which will join the two fiber. Now via this optical fiber, sometimes we want to couple the signal. Okay, sometimes you want to couple the particular signal and it is given to the other equipment. So we need to go for the use of the splitter, and that is particular the splitter will split the signals. It is given to the optical receiver. Now we have the repeater in between or the regenerator in between. So that is the optical transmitter, over here the optical receiver. Between that, there is a repeater. As we know that whenever the distance that is large, then at that time we need to amplify or we need to regenerate the particular signal. We need to restore the particular signal shape. And that is why the kind of the devices that is used in between, so that it can protect the particular signal and whatever the form which we have used in the transmission, the same thing that we received at the receiving end. So we have the optical amplifier. Now that optical amplifier signal, it is connected via the fly lead and given to the photodetector. But we don't understand the form of the signal, that is the light. So always we need to convert that light form of the signal into the electrical form. So at the optical receiving end, we need to go for the use of the photodetector. And that photodetector which will convert the light pulse into the electrical form, and that particular signal, okay, again it travels the longer distance, and that is why we need to amplify that signal. So here to improve the gain of the receiver, we have used the particular amplifier. And to get the original signal shape, we need to use the signal restorer. And we have the original signal that comes out from this, and whatever you have transmitted from the transmitting end, you receive those signals at the receiving end. So it is about the block diagram of the communication, fiber optic communication. So at the transmitting end, electrical signal is applied to the optical transmitter, which consists of driver circuit, light source and the fiber fly lead. Okay, what is the use of the driver circuit? Drives the light source. Light source, what it will do? Converting the electrical signal into the optical form. Fly lead, that is used to connect optical signal to the optical fiber. There is a fly lead that can be used. Okay, now in the transmission channel, what is over here? The fiber optic cable. It can be the coaxial cable, copper wire in the ordinary phone system. So it consists of the cable that provides the mechanical and the environmental protection to the optical fiber connections connected inside. As we know that the fiber optic cable installation, that can be anywhere. It can be under the ground, under the sea. Now when it is under the ground, it comes under the pressure. When it is implemented under the sea, we need to protect it from the water animal. The big vehicles are there, water vehicles are there, okay, over the particular sea. So that is why, okay, we need to go for the optical fiber, okay, and it is connected with the particular kind of the material to protect the fiber or to provide the strength to the optical fiber. So it can act as an individual channel. Now, optical splice that is also used, okay, to join the individual optical fiber. Optical connector, that is for temporary non-fixed joint between the two individual optical fiber. The optical coupler or the splitter that provides the signal to the other devices. If you are using the other devices with the same input, you need to divide that. So that is why you can go for the use of the splitter also. Okay, so that is about the transmission channel. Again, the repeater that we have seen in between. So the repeater that converts the optical signal into the electrical signal, okay, using the optical receiver, and passes the electronic circuit where it is reshaped and amplified as it gets attenuated, distorted with increasing the distance because of the scattering, absorption and dispersion in the waveguide. And this signal is then again converted into the optical signal by the optical transmitter. So this is about the transmission channel. What is the last portion? Optical receiver. So optical signal that is received by the optical receiver, which consists of the photodetector, amplifier and the signal distorter. What is the photodetector? Converting the optical lights into the electrical signal. The signal restorers and the amplifiers that are also used to improve the signal to noise ratio of the signal, as there are the chances of the noise to be introduced in the signal due to the use of the photodetector. If the amount of the noise is less, then the signal to noise ratio that is higher. So that is always our demand, to have a good SNR at the receiving end. So now some important points to remember, that is for the short distance communication and the long distance communication. So in the short distance communication, the sources are required for converting the electrical input signal into the light form, that are the LED. The fiber we need to use, it's a multi-mode step index fiber. Detector, that is the beam detector we can use. Similarly, for the long distance communication, the main elements, that are the couplers we need to use. We need to go for the beam splitter, repeaters and the optical amplifiers. These all are the added elements in case of the long distance communication. So that are the source instead of the LED, go for the laser diode. Multi-mode, go for the single mode fiber, and the pin detector were used in case of the short distance. In case of the long distance, avalanche photodiode APD can be used in the case of the communication. So this way the elements that can be used, and it also depends on the distance to be covered in case of the communication. So thank you very much everyone.